So the biggest thing we want to do on all of these problems that are rational expressions, either simplify, multiply, or divide, or the biggest task I think you guys are going to have is factoring. It's really important that you check your factoring, because if you have the wrong, like plus or minus, either something might cancel that isn't supposed to, or nothing might cancel because you don't have common factors. So at the denominator here is a little bit easier to factor. I can see right away that I can pull out a GCF of 6. If I do that, I end up with x squared minus 9 in the denominator, and I'm going to still have this up here. And then if you've got to recognize that this is going to factor some more. So that's going to actually become x plus 3, x minus 3. Okay, so the denominator's all factored, and the reason I did that one first is because it might help me factor the numerator. So if I have factors of x plus 3 and x minus 3, probably one of the factors in the numerators is also going to be either x plus 3 or x minus 3. In the numerator here, 6, 15, and 9, if you see it, there's actually a GCF of 3. So I'm going to off to the side just pull the 3 out. That leaves me 2x squared minus 5x minus 3. And so then I'm going to bring that down here, and now I'm going to factor that trinomial, this 2x squared minus 5x minus 3. And again, I'm thinking that one of these is going to be in there. So I know I'm going to start with a 2x and x to get 2x squared, and I know I'm going to use 3 and 1. And I'm thinking I'm probably going to put the 3 over here and make that one negative, so that gives me negative 6x, and then I will add 1x. So that's going to give me negative 5x when I add them together, but when I multiply when I multiply positive 1 and negative 3, I'll get that negative 3. Okay, so now we're going to cancel things, and then the 3 and the 6 can reduce, so that becomes a 1, and that becomes a 2. So the answer here is 2x plus 1 over 2x plus 3. Now remember, we've got to look for domain restrictions. You can never divide by 0, so you're not allowed to have a 0 in the denominator. So what would make this denominator equal 0? Well, there are going to be two numbers that I can see from right here. So negative 3 plus 3 would equal 0, so x can't equal negative 3. And positive 3 minus 3 would make that one equal 0. So even though this cancels out, you still have to list it as a domain restriction. If we were graphing this function, there would actually be a hole in the graph right there. So it's a spot where the graph doesn't exist.